Hello and welcome to this episode of the Classics. Today I'm going to look at this exercise. That is actually a bunch of exercises that I compiled. So we have stuff with the sum of 1 over n and the comparison to 3n over 2n plus 1, factorial 2n plus 1, well, the product of these factorials, to be superior at the n plus 1 factorial to the power n plus 1, and then the sum of the xn to times the sum of 1 over xn be superior to n squared. So it's number 15. So let's scroll down. Well, I can just roll like this: 15, 15, 15, 15. So I'm going to take n equal 2, so this is verified. So we're going to do something like induction or récurrence in French. So this is verified for n equal 2, so the lowest rank of this property. So we have this by the hypothesis of induction, and then we're going to add 1 over k plus 1 squared in both sides of the inequality. I call delta to be this thing, and then I put it in a single fraction and I get this, and this is actually positive or 0. So I then put that being I then put that as being superior to this, since delta is positive. So I can say that this is superior to this. So I do this inequality, and then I just replace in the original equality, and I get the truth for the next rank. So the property is verified for n equals 0, and so oops, that's for the next question. But so the property is proved for all n superior to 2. So next question is just the product of the factorial n plus 2n plus 1. So for n equals 0, it's verified. Now I suppose it's true for an integer k. So we get this inequality, and then I multiply by 2k over 3. Oops, factorial 2k over 3. It's a mistake. Yeah, multiply by factorial 2k over 3 in both sides of the equation. Then I calculate this thingy here that equals to this, and that's equals to this, and that is superior to 1. That means that this is superior to this. Well, no, this times this is superior to this. So we get this inequality, and actually it proves the hypothesis in recurrence by replacing in there here, because you get the next rank. So this proves the property by induction, not recurrence. Induction. So the next property, if n equal to 1, x1 times 1 over x1 is equal to 1, so that works. We suppose that the property is true for an integer k, so we get this. Okay, so now I call a to be equal to the sum of the xk, and b to be equal to the sum of the 1 over xk. So I calculate this product, that is equal to ab plus ab over xk plus 1 plus b times xk plus 1 plus 1. So by hypothesis, AB is superior to n squared because of this thing here, because that's A, that's B, and that's n squared. So then we have this inequality. It comes from just developing this. Just develop it, you'll get it fairly easily. So you get this inequality, and then you replace. So A is a over x k plus 1. B is equal to bxk plus 1. 2 is 2. And then you replace, you'll get this inequality here. And you notice that you have 2 square root of AB, and square root of AB is n. Well, is as we've seen earlier, AB is superior to n squared. Yeah. So 2 square root of AB is superior to 2n. So we get in this inequality, and by replacing we get this inequality. And that's it. By induction, sorry, it's demonstrated. Induction, it's demonstrated. So that's it. Thanks for watching. If you have any questions, feel free to ask them in the comment. I'd be glad to answer them, and bye.